Okay, in this session we're going to have a look at Unit 4, Chapter 4, Trigonometry in a Unit Circle. We'll be looking at angles and angle measures, Part 2. In particular, we're going to be looking at coterminal angles and arc length. So as I said, the focus is going to be on determining the measure of angles that are coterminal with a given angle. And we're going to be solving problems involving arc length, central angles, and the radius of a circle. Okay, let's have a look at coterminal angles first of all. When you sketch an angle of 60 degrees and an angle of 420 degrees in standard position, the terminal arms coincide. These angles are considered to be coterminal angles. So an angle of 60 degrees is right here. An angle of 420 degrees is right here. I've rotated 360 plus another 60, and you can see that it has the exact same terminal arm as the angle of 60 degrees. If they have the same terminal arm, then the angles are considered to be coterminal angles. Coterminal angles, angles in standard position with the same terminal arm as I just stated. You may see them measured in both degrees and radians. For example, pi over 4 and 9 pi over 4 are considered to be coterminal angles, as are 40 degrees and negative 320 degrees. Let's have a look at those two examples. Pi over 4 and 9 pi over 4. Pi over 4 is 45 degrees. That's approximately right here. It's pi over 4. 9 pi over 4 is an angle measured in the positive direction. And if we rotate 9 pi over 4, we make one complete revolution. That is 8 pi over 4. Because remember, this here is 2 pi. One complete revolution is 2 pi, or 8 pi over 4. So we need to go another pi over 4 beyond that to get 9 pi over 4. So if I rotate another pi over 4, you see I will stop at the exact same location, at the exact same terminal arm. So we say again that pi over 4 and 9 pi over 4 are coterminal angles. The same is true with 40 and negative 320. Let's rotate 40 degrees and negative 320 degrees. If I rotate 40 degrees, I will have a terminal arm at approximately this location. And again, this is only approximation, but there's an angle of 40 degrees. If I rotate, again, I always measure from the positive x-axis an angle in standard position, negative 320. Let's rotate in the negative direction 320 degrees. That's an angle of negative 320 degrees. And note again that both of them have the same terminal arm, therefore they are coterminal. So look at some more examples. Identify coterminal angles. Determine one positive and one negative angle that is coterminal with each of the given angles. In which quadrant does the terminal arm lie? 40-degree angle, we are looking for a positive angle and a negative angle coterminal with 40 degrees. I think I just did that one on the last slide there. 40 degrees, if we were to look at the negative angle of rotation, which is the one that I just did, negative angle of rotation, we rotate in the negative direction, like this. That would be negative 320 degrees. That's a negative angle of rotation. That's coterminal with 420. And if I rotate in the positive direction, I would get this angle. So I need to rotate in the positive direction until I hit the terminal arm again. There it is. That positive angle of rotation would be 360 plus 40. I've gone around once, plus I go another 40 degrees, which will equal 400 degrees. So there's an angle of rotation that's coterminal with 40 degrees. There's my positive angle, there's my negative angle. Let's do the same thing with B, negative 430. And it does ask which quadrant does the terminal arm lie. Clearly it's in quadrant 1, right? Quadrant 1. Okay, let's have a look at negative 430, as I said. Let's quickly draw where negative 430 degrees is located. Negative 430. We make one complete rotation, that's negative 360. and I need to go another 70 degrees beyond that. Negative 360 and 70 will bring me to negative 430. So there is where my terminal arm is located, approximately right here. Negative 430 degrees is the angle that I'm looking at. Now, I'm looking for two angles that are coterminal with that angle, one positive and one negative. A positive angle that's coterminal with that angle would be this one. Now remember, I went an extra 70 degrees beyond 360 in the negative direction. So the positive angle of rotation would be 290 degrees. 290. It's 270 from there to there, and another 20 degrees from there to there. Because remember, this reference angle we call it is 70 degrees right there. That's the reference angle from there to there. So the positive angle of rotation is 290. The negative angle of rotation is actually negative 70 degrees. It's equal to the reference angle, negative 70. We rotate in the negative direction until we hit the terminal arm, negative 70. We rotate in the positive direction until we hit the terminal arm, positive 290. C, 8 pi over 3. 8 pi over 3. Let's construct approximately where 8 pi over 3 is located. You want to start thinking in terms of radian measure as well. Remember that this is pi, which will equal 3 pi over 3. This is equal to 2 pi, which is equal to 6 pi over 3. And if I were to continue to rotate, this would be 3 pi, 6 pi, 9 pi. Would be located right here. I'm not at 9 pi, I'm at 8 pi. So I want to rotate 8 pi over 3. So let's think about where that will be located. That's 3 pi over 3. That's 6 pi over 3. I want to go 1 pi over 3 less than 9 pi over 3. Bringing me all the way around, again, would be 9 pi over 3, not all the way, but of course at pi. So I'm 1 pi over 3 less than that. That would be 8 pi over 3 right there. 8 pi over 3. Think of it again, 3 pi over 3, 6 pi over 3 is 2 pi, 9 pi over 3 will be right here. I'm 1 pi over 3 less than that. So that's 8 pi over 3. I'm looking for two angles that are coterminal with 8 pi over 3, one positive and one negative. There's my negative angle of rotation. That would be negative 3 pi over 3, and a negative 1 pi over 3 is a negative 4 pi over 3. I don't need two negative signs there. Get rid of one of those. Negative 4 pi over 3. Because I'm rotating in the negative direction, this is now negative 3 pi over 3, which is pi, of course, right? Negative pi. Negative 3 pi over 3, and that's 1 pi over 3 right there. That's my reference angle, pi over 3. So I got 3 pi over 3 and 1 pi over 3 is 4 pi over 3 in the negative direction. And if I rotate in the positive direction, I will get this angle of rotation. That angle of rotation right there is 1 pi over 3 less than 3 pi over 3, which of course would be 2 pi over 3. There's the measure of the angle in the positive direction, and you can see that this terminal arm lies in quadrant 2, this terminal arm lies in quadrant 4. So there's a couple of examples of coterminal angles. Let's look at coterminal angles in general form. By adding or subtracting multiples of one full revolution, we can write an infinite number of angles that are coterminal with a given angle. For example, some angles that are coterminal with 40 degrees are 40 plus 360 times 1, 40 plus 360 times 2, 40 subtract 360 times 1, negative 320, and 40 subtract 360 times 2, or negative 680. All we're doing here is we're adding or subtracting 360 degrees from the given angle of 40 degrees. So let's just do a quick sketch of my diagram here. Here's the angle of 40 degrees approximately. What we're simply saying is this: if I continue to add one complete rotation, I will always get a coterminal angle, or two complete rotations, or three complete rotations. So angles that might be coterminal with 40 degrees, or that are coterminal with 40 degrees, would be this. That's an angle coterminal with it, you see, which is 360 plus 40, which is your 400 degree angle. Another angle coterminal with it, if we were to rotate more than once, in a second here, I draw the diagram for you. If we were to rotate more than once, that's once, we're going to go around twice this time. Now you see I've gone 720 plus 40, which is 760. Again, note the two answers that are here. I can continue to do that. I can go around 3 times beyond my 40, and I will get the next coterminal angle, and it continues on forever and ever in reality. Of course, we can also go in the negative direction and subtract 360, and we will again get angles that are coterminal with 40 degrees. So here again is my reference angle, right here, or my terminal arm. If I rotate in the negative direction, that's an answer. That's an answer of 40 subtract 360, which is negative 320. As you can see, if I continue to rotate in the negative direction, and don't stop at that terminal arm, but actually continue around one more time, starting here again in the positive x-axis, I rotate around. Now I've rotated negative 360 and a negative 320, which is a negative 680, which is actually 40 minus 360 times 2, which will give me a negative 680. That's the measure of that angle. And again, note the angle right there. We can actually write all the angles that are coterminal with 40 degrees as 40 plus or minus 360n, where n is a natural number. 40 plus or minus 360n, where n is a natural number. Again, we can continue to use values of n, positive values right here and negative values, or just subtract 360n. Both of these will give us angles that are coterminal with 360. The same is true, by the way, with angles in radian measure, like 2 pi over 3. I can add 2 pi times 1, and I will get 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. That angle is coterminal with 2 pi over 3, I assure you. If I add 2 pi over 3 plus 2 pi times 2, 2 pi over 3 plus 12 pi over 3 would be 14 pi over 3. That angle again is coterminal with 2 pi over 3. In a similar way, I can subtract 2 pi times 1 and subtract 2 pi times 2 and so on, and all of these angles are coterminal. 8 pi over 3, 14 pi over 3, negative 4 pi over 3, negative 10 pi over 3. And there are many more that are coterminal. And again, in general, the angles that are coterminal with 2 pi over 3 are simply 2 pi over 3 plus or minus 2 pi n, where n is none of the natural numbers. Now remember, the natural numbers start with the number 1. There's our natural numbers. So as long as we plug in a natural number, we will be getting angles that are coterminal with the given angle. So look at some examples. Which angle in standard position shares the same terminal arm with negative 16 pi over 3? Again, you can pause the recording here and try this one first, if you wish, before I actually do it. Negative 16 pi over 3, I always suggest you draw a diagram to get some idea what the angle looks like. So we're rotating in a negative direction, so we start on the positive x-axis, and we rotate negative 16 pi over 3. If we go around once, that's a negative 6 pi over 3, because that equals a negative 2 pi. If I do the exact same thing again, I've now gone around negative 12 pi over 3, because that equals a negative 4 pi. I need to go another 4 pi over 3 in the negative direction, another 4 pi over 3. If I go right here, that's another 3 pi over 3, because that's pi. So that's now negative 15 pi over 3 as far as here. I've got a negative 6, negative 12, negative 15, and I need to go one more pi over 3, and then I draw my terminal arm. There's approximately where the terminal arm is going to be located. That's negative 15 pi over 3. Note the reference angle here is pi over 3. That's my reference angle. The reference angle is the angle measured from the negative x-axis, in this case, to the terminal arm, pi over 3. We're looking for an angle in standard position that shares the same terminal arm. Angle in standard position that shares the same terminal arm. Pi over 3, you should know, is 60 degrees. So, is negative 150 coterminal with that? No. Negative 150 will be located somewhere in this quadrant, rotating in the negative direction. Positive 120. If I were to rotate positive 120 degrees, I would get the exact same terminal arm. So positive 120 is coterminal with negative 16 pi over 3. The most difficult part of that question was actually rotating negative 16 pi over 3. Now you could have changed it from radians to degrees if you wish and done it in degrees. Wouldn't have mattered. You still should get the same answer, of course. Example 3. Which expression gives angles that are coterminal with 3 pi over 4 in general form? 3 pi over 4 is 3 pi over 4 plus or minus 2 pi n, where n is an element of the natural numbers. That's what we just learned. 3 pi over 4 plus or minus 2 pi n, where n is an element of the natural numbers. Correct answer is D. Example number 4. What angles are coterminal with 4 pi over 3 within the domain between negative 4 pi and positive 4 pi? Okay, let's do this one. Looking for coterminal angles to 4 pi over 3. Let's figure out where that's located. If I rotate in a positive direction, it's a positive angle of rotation. This is 3 pi over 3. I need to go to 4 pi over 3, so I need to go another pi over 3 beyond that. So there's my terminal arm right there at 4 pi over 3. Remember that the reference angle is pi over 3. The reference angle is the angle measured from the negative x-axis to the terminal arm in this case. Now, I am looking for all the angles that are coterminal with 4 pi over 3 between negative 4 pi and 4 pi. Now, you want to think about what this restricted domain looks like. Between negative 4 pi and 4 pi is really one complete rotation in the positive direction, or actually, sorry, 2 complete rotations in the positive direction, and 2 complete rotations in the negative direction. So I go around twice in that direction. That's between 0 and 4 pi. And I also need to go around twice in the negative direction. This is between negative 4 pi and 0. That will give me my answers between negative 4 pi and positive 4 pi. You can see that there are going to be 4 answers here, I think. Okay, we see that they're only showing 3 answers, so we'll check and see what happens there. But we got a terminal arm located here. We got a terminal arm located here. And let's see what our answers are. 4 pi over 3, rotating in the positive direction. That's one answer. 4 pi over 3 is an answer, you see. So we're looking for the angles that are coterminal with 4 pi over 3. So we're not going to consider 4 pi over 3 as an answer because it's not coterminal with itself. That's why there's only 3 answers here, not 4. So we're rotating in the positive direction, 4 pi over 3. We already got that one. If we rotate again in the positive direction, we got another answer here, which is going to be 4 pi over 3 plus 2 pi, right? Because we've gone around one more time. That's going to be 4 pi over 3 plus 2 pi times 1. which is going to give me an answer of 4 pi over 3, 4 pi over 3 plus 6 pi over 3, which equals 10 pi over 3. Okay, 10 pi over 3, so we've narrowed it down to being one of these two answers here. Now in the negative direction, look at this diagram here, we're rotating in the negative direction. That will be negative 2 pi over 3. Negative 2 pi over 3 will be an answer. You can look at it this way as 4 pi over 3 subtract 2 pi, which will be 4 pi over 3 subtract 6 pi over 3, which is a negative 2 pi over 3. So there's an answer, negative 2 pi over 3. The answer has to be C now, because negative 2 pi over 3 is not listed in D. We knew there had to be 3 other answers besides 4 pi over 3, so we knew it had to be C or D. It can't be D because of the negative 2 pi over 3 is not listed here. Of course, we can find the other one as well. If we continue to rotate, I can subtract 2 pi over 3 twice, and I should get the fourth answer, or the third answer, sorry. 4 pi over 3 subtract 2 pi times 2, and I get 4 pi over 3 subtract 4 pi, which is 4 pi over 3 subtract 12 pi over 3, which will give me negative 8 pi over 3. And again, there is my third answer. So these are the 3 angles that are coterminal with 4 pi over 3. Okay, moving right along, we're going to have a look at arc length now. Earlier you learned the formula that an angle measured in radians is equal to the arc length divided by the radius. If we simply manipulate that formula, we'll get arc length by cross multiplying. Arc length is equal to the angle in radians times the radius. In a simpler version, A is equal to theta times R. A is the arc length. Theta is the angle in is the angle measured in radians. R is the radius of the circle. We can use this very simple formula to help us find arc length or any of those 3 unknowns. Let's have a look at a couple of examples. What is the exact length of an arc with a central angle of 140 degrees in a circle of radius 9 centimeters? So, we just learned that A is equal to theta times R. What is the exact length of an arc? So we're looking for the arc length with a central angle of 140 degrees in a circle of radius R. So we know the radius is 9. The issue here is that the angle is given to us as degrees. We need to change our 140 degree angle to an angle in radian measure. To change from degrees to radians, we multiply by pi over 180. When we do that, we get 140, if I simply reduce, I'll get 14 pi over 18. Continuing to reduce, I'll get 7 pi over 9. 7 pi over 9. So, therefore, the arc length is equal to 7 pi over 9, because the angle got to be measured in degrees, in radians, it was given in degrees, times 9. Of course, the answer is going to be 7 pi centimeters. 7 pi centimeters. Another example, the length of an arc subtended by a central angle of 80 degrees is 2 pi over 9. What is the radius? Simply use our same formula again. A is equal to theta times R. Now this time we're given the measure of the arc. The measure of the arc is 20 pi over 9. We're given the measure of the angle, but again, note the angle is in degrees. I need to change that degrees to radian measure. Always got to be in radian measure. That's very important. Got to be in radian measure. And if it's not, we need to change it, which I'm doing. That's going to give me 80 pi over 180. If I reduce that, of course, I get 8 pi over 18. Continuing to reduce, I'll get 4 pi over 9. 4 pi over 9. So I get 4 pi over 9 times the radius, that's what I'm looking for, R. Now, I want to get R by itself. The simplest way to get R by itself is to multiply this side by, 9 over 4 pi. And of course, I multiply the other side by 9 over 4 pi. 4 pi over 9 times 9 over 4 pi will give me 1r. Here the 9's will cancel. You're left with 20 over 4, which is 5. The pi's will cancel as well, of course, right? So we're left with 20 over 4, which is 5. The radius of this circle is 5. Okay, key ideas. Angles that are coterminal have the same initial arm and the same terminal arm. An angle theta has an infinite number of angles that are coterminal expressed by theta plus or minus 360 n, where n is an element of w in degrees, or theta plus 2 pi r, where n is an element of w in radians. I think they're supposed to be the natural numbers here, not w. The natural numbers. That's looking for angles that are coterminal. The w there is the whole numbers. The whole number includes 0. So if you include 0, then you're including the angle itself as being one of those angles. So I much prefer that it be written as n is an element of natural numbers, as you saw in the lesson itself. The formula A is equal to theta times r, where A is the arc length, theta is the central angle in radians, and r is the length of the radius, can be used to determine any of the variables given the other two, as long as A and R are in the same units. Okay, that ends this particular lesson.